Hi guys, welcome back to VKEngine. Last time we had a simple triangle on the screen, and now we'll extend it to be a bit more interesting than that. So the simplest next step would have been to use push constants to get data into the shader, but instead I went ahead and implemented the full suite of objects. So now I have a vertex buffer, an index buffer, uniform buffers, and textures, as well as descriptor sets to bind those resources to the shaders. So the way I'll do these videos is I'll share some visual results first, and then I'll discuss some technical details. Now the first thing I did was to get this quad spinning in perspective projection view, and this is done by updating the MVP matrix, so that's the model, view, and projection matrix, inside the uniform buffer every frame using a timer. And next I applied a texture to the quad. So I created the GPU image abstraction, which wraps together a VK image view, and a VK sampler, and then I bounce that resource to the shader using a descriptor set. However, you can see when we try adding a second quad in a different part of 3D space, that the depth isn't resolving properly, and this is because I don't yet have depth testing set up. One workaround is to manually sort and draw the objects back to front, and this does work, and is actually one of the techniques used for rendering transparent objects with alpha blending, but it's not suitable for opaque geometry. However, GPUs have a fixed function depth test stage, which uses a depth buffer to resolve this issue, and that's what we'll implement support for next, so that opaque geometry renders correctly without needing to be manually sorted. And after that, we'll be ready to load and render a full 3D model. So here's what the architecture looks like right now. I've added 4 objects since last time: vertex, GPU buffer, GPU image, and descriptor manager. And I'll just show you the headers. So this is the vertex definition. It describes the position, color, and UV data layout for a single vertex, and also provides the binding and attribute descriptions that Vulkan needs for the pipeline's vertex input state. For the GPU buffers, the implementation of vertex and index buffers is quite straightforward. I'm using the staging buffer pattern to map the data onto the device local memory of the GPU to ensure the fastest access speeds. And with regards to uniform buffers, we require one for each frame in flight to avoid CPU-GPU synchronization issues, and also they should be persistently mapped so that we can simply mem-copy the data over each frame, rather than constantly mapping and unmapping the buffer. And a common optimization is to pack both vertex and index data into a single VK buffer and just bind using different offsets, which I'm going to do later. For the GPU images, I built a small wrapper class around the VK image view, and the VK sampler, as well as a function that loads the image. And all of the operations for loading an image are recorded into a single command buffer here, and then submitted once, which saves a little bit of CPU overhead. So one optimization I still want to do is to allocate temporary command buffers from a transient command pool instead of using the main one, and that also applies to loading the vertex and index buffer. Now finally, my descriptor manager is a thin wrapper around descriptor pools and descriptor sets using the classic Vulkan API, and in the future I want to move to a more modern descriptor indexing approach, which is basically using one big descriptor set that you can index into in the shader, which just cuts down on the bookkeeping you need to do application side. So as always, thanks for watching. You can find the source code link below, along with some resources for learning computer graphics programming, and I've extended the Vulkan section on my site, so check that out if you're interested, and thanks for watching.